Hey, pre-calc class, do my best to keep this short and wrap up the notes that we started earlier today. We just left off talking about coterminal angles, angles of rotation who end in the same positions. We have these different pieces with the terminal sides of our angles, starting always at the positive horizontal axis and rotating. Positive is counterclockwise, negative is clockwise. And yeah, we have angles that can theoretically end up in the same location. So I'm going to draw a couple of examples of that. So let's say we had an angle theta that was 104 degrees. Right? So I draw my UV coordinate system. We always need to have some sort of coordinate system for this. 104 degrees is going to be just past 90, 14 degrees into quadrant 2 here. So I have my angle there. Right? And there's my angle theta. That's 104 degrees. Right? In another UV coordinate system, right, I can have another angle that would end in the exact same spot. Right? Let's say I had an angle that ended here but got there a different way. So instead of going just from here to there, let's say it went there but continued around and did another full rotation, 360 degrees past that. Right? That could be my angle phi. That Greek letter phi would be 464 degrees. And I know that these are coterminal because 464 degrees is 104 degrees plus 360 times a multiple of, in this case it's just one, right? It's one full rotation past the 104, one multiple of 360 away from that 104 degrees. Let's do one other one that's coterminal to this. And I've got my UV system here. I already know I'm trying to draw a coterminal, so it has to end in the same spot, so I will just mirror that here. But let's go maybe a different way. Right? Let's go a negative. So start there and end, not there. Let's do one that goes all the way around to there. Right? We'll call this angle beta, Greek letter beta. Get used to some of those Greek alphabet things. Would be negative 616 degrees. And I know that these are coterminal because negative 616 is 104 degrees. It has to be plus 360 times some multiple. In this case, the multiple is negative 2. Right? I always have a plus here. Right? I don't do plus or minus there. I just know that my n, my multiples of 360 away from that original angle could be positive or could be negative. That's a hang up for a lot of people later on when we get to chapter 3 especially. So just kind of get used to always writing a plus here. Always, always, always positive 360 plus a multiple of 360, but the multiple could be negative. Right? In this case, that would be negative 720, and 104 plus negative 720 would be negative 616 degrees, all coterminal to each other. So that's the terminology that we use, is that these angles theta, phi, and beta are all coterminal to each other. And we can describe all of the angles that are coterminal to 104 would be 104 degrees plus any whole number multiple of 360 degrees away from that 104 degrees. All right, last bit of vocab I want to talk about. This is our third kind of piece. We have standard position, we have coterminal angles, and now I want to talk about something called reference angles. We use this a lot in the next 2 chapters. Okay. So a reference angle is kind of a way for us to boil all of these angles of rotation down into something, down to an acute angle, basically, right? Down to something that we could measure in a right triangle, say. Right? So these reference angles are how we take these angles, these more than 360 degrees, these negative angles, and it's a way to refer to that knowledge that you already have from geometry. Right? These reference angles are creating an acute angle, right? That's positive, that, right, you could remember as what's the sine of 70 degrees? You did that in right triangle geometry, right? That opposite over hypotenuse. It's a way to kind of tie things into those things that you already know. So a reference angle, and I'm going to zoom in here, make my handwriting a little bit better. A reference angle to an angle in standard position has 3 things that need to be true about it. Right? So this is we got 3 different cases. It's positive. So it is the positive. Second thing that has to be true about it is it has to be acute. It's always the angle between and this is the third condition, always goes to the horizontal axis and the terminal side. So this basically reads as one long sentence, right? A reference angle to an angle in standard position is the positive acute angle between the horizontal axis and the terminal side. That's how it's defined in the book. But I really want to separate and highlight out, right? There's 3 conditions. The angle has to be positive, it has to be acute, and it always goes to the horizontal axis, not the vertical axis. So let's, right, and we have a shorthand abbreviation for this, right? You'll see this a lot. We abbreviate it as that theta, and then we'll write down here ref for reference angle. So this is what I mean. Okay. Let's do an angle here. Let's pick a different color. We'll do a 130 degree angle here. Out in quadrant 2 there. So if I have my angle theta, that's 130 degrees, right? That's not something that we're used to doing any trig on, right? You're not used to taking the sine of 130 degrees or the cosine of 130 degrees. Everything that you've done so far has been on positive but acute angles, right? The sine of 70, the sine of 40, the cosine of 20. Right? So we want to find a way to tie that 130 to that, right, that prior knowledge. And so we want to find something that's a positive angle. Positive means it has to be rotating, right, counterclockwise. It has to be an acute angle, and it has to be between the terminal side, so this branch here, and the horizontal axis. So in that case, this is my angle right here. Right? Let's pick a different color. This is my angle. This is an acute angle here, right? This is an obtuse angle, this 130 degrees, more than 90. Here's its acute partner, right? It's not this one here. It's not up between the terminal and the vertical. It has to be between the terminal and the horizontal axis. And then kind of the last piece I do on it is that I make it positive by adding on this arrowhead there, saying, right, I'm keeping that positive rotation. It's a positive angle. So this here, this angle, is not in standard position, right? Standard position has to be like starting at the horizontal axis. This angle starting at this terminal side, going to the horizontal axis, but it is my reference angle. And there will be a lot of similarities between the trig values of this reference angle that you're used to and the trig values of this 130 degree angle that we will explore later. All right, so let's look at another example. We'll do 242 degrees, so something like down here. Right. So here's my angle, right? My theta, it's 242 degrees, and I'm going to go ahead and just quick change this color. Sorry about that. I really like consistency. So if I'm trying to find the reference angle for this angle in standard position, right? It's going to be right here, right? I just continue on from the terminal side until I get to the end. And maybe some of you are thinking, wait, no, stop. You said it has to go between the horizontal side and the horizontal axis and the terminal side, and you would be correct. Right? This is not the reference angle. It is not this continuation. This one was, this one is not. Right? So it's got to be from the terminal side to the horizontal axis, right? This rotation that way going back between the terminal side and the horizontal axis. Except that is not positive, right? We've already defined earlier on, right? Clockwise rotation is negative, counterclockwise is positive. So if I have my arrowhead here, right, that's going clockwise. This would be a negative angle, and I said that it had to be positive. So that's not it either. It's this one, right? This is my reference angle in this case. It's between the horizontal axis and the terminal side, but it doesn't start at the terminal side like this first example did. It starts at the horizontal axis. Right? And I can measure it. Right? It's like, how far past 180 did I have to go? I went 62 degrees past 180. Right? We'll do one last example, an example in quadrant 4. Right. We'll do out here, say we have a 312 degree angle. Right. So this would be my angle of rotation. My theta is 312 degrees. The reference angle, right, is between the terminal side and the horizontal axis. So it's going to go this way this time, right? It's not going to the negative or from the negative. It's this one because that's my acute angle, right? And my reference angle there is like, how far away am I from 360 degrees? Because 360 is back there, right? And it's 48 degrees away from the 360 mark. That is my reference angle. The trig functions, the trig ratios that you've talked about with this 48 degrees are going to be very closely tied to that 312 degrees. So I'm going to give you 2 quick questions that I want you to work on before you come to class tomorrow. All right. So 2 questions. I'm just going to write them here. Okay, 2 questions here that I want you to think about. First, let's take this out to ridiculous lengths. If theta was 7,043 degrees, where is that angle, right? What would that angle look like in standard position? You can skip all of the loops around, but try to accurately get what quadrant will it end in, right? What is a coterminal angle maybe between 0 and 360 that would give you some kind of marker for where it should be, and how could you figure that out mathematically? Right? And then mark the reference angle and find its measure. So one question I'd like you to work on a little bit. Second question, find the first angle more than 8,000 degrees, coterminal to 306 degrees. So when I say first angle more than 8,000, right, you could add on, right, 100 360s to this, right? So you do 360 times 100 would be 36,000, and then just, right, 306 past that. That would be one, but I want you to find what's the one that's closest to 8,000 degrees? What's the one that's more than 8,000 degrees, but closest to that would still end in the same location as a 306 degree angle? And we'll talk about those when you come to class tomorrow.